Welcome, everybody, to episode 8 of the London Futurist podcast. And David and I are beyond excited to have as our guest today the very well-known AI researcher and practitioner Daniel Hulme, who founded what I think was London's largest independent AI consultancy before it got bought earlier this year, or was it last year? Earlier this year, by WPP, which of course is one of the world's communications giants. It owns JWT and all sorts of other ad agencies and marketing agencies. So Daniel is not only the founder and CEO of Satalia, which he still does, but he's also the worldwide global AI lead for WPP. If that wasn't enough, he also founds all sorts of strange new activities and owns a few parrots. So welcome, Daniel. I'm sure I've got some of that intro wrong, so this is your opportunity to correct it.
No, that's all good, Callum. I'm even more excited to be here. Thank you.
It's great to have you here, Daniel. I'm looking forward to some pearls of wisdom. Many companies are struggling with the right ways to deploy AI, and I'm sure you can give some thoughts as to how it will go smoothly and effectively rather than end in tears.
Yeah, indeed. So as Callum said, I still maintain my relationship with UCL, which is one of the world's leading universities in AI. I'm entrepreneur in residence, but in UCL, I did my undergraduate, my master's, my PhD, postdocs, all in AI. I ran a master's program where I had hundreds of students going out there applying these emerging technologies to solving problems across a whole range of different industries. So I got a very good sense about where companies are at in terms of their digital transformation. Yes, I'm still the CEO of Satalia, and I'm the Chief AI Officer for WPP.
And before we move on from your background, am I right in thinking that you had a hand in the formation of DeepMind?
Not the formation, the spinning out of DeepMind from UCL. So as part of my relationship with UCL is helping understand how to do technology transfer, and so we were helping understand what IP could and should be spun out from UCL to DeepMind.
Cool. Okay, well, let's get into the heart of things. So I think everybody doing any sort of any serious job anywhere is well past the phase of wondering, is AI important? And well into the phase of wondering, how on earth do I deploy AI in my organization? But there's still an awful lot of confusion and misunderstanding about what AI is and what it can do. So let's start with, what is AI good at right now? What can it do for organizations today?
Yeah, so I think a lot of people are thinking AI as essentially computers to do things that humans can do. We've seen obviously massive advancements in deep learning over the past decade that now allows us to build AIs that allow us to do things that traditionally only human beings can do, recognize objects and images and correspond in natural language. And that's what people are currently calling AI, and I guess where a lot of the excitement is around. But if I'm being honest, I don't see a huge amount of meaningful material impact on organizations using those types of technologies just at the moment. AI, I think, has a slightly more robust definition, which comes from the definition of intelligence, which is goal-directed adaptive systems or goal-directed adaptive behavior. So systems that can essentially make decisions and adapt themselves based on the decisions that they're making. And if I'm being brutally honest, we don't tend to see adaptive systems in production. So even to that definition, I would argue that nobody's really doing AI. So what I've been trying to do, instead of using these definitions that I think are not so useful for business, even things like narrow AI and strong AI and general AI, what I've tried to do is categorize how AI is being applied in organizations. And I think there are broadly 6 categories. So that the first category is task automation. So that's using, I guess, the cliche if then else statements, very, very simple algorithms to automate human tasks, whether that's macros or tracking what people do on the screen and then building robotic process automation to replace that human being. So that's using relatively simple technologies to automate relatively simplistic human tasks. The second category is generative AI, and we've seen obviously over the past few months an explosion of real interest around the generation of video, images, text, and the expectation is that we use this to be able to augment the creative processing in creating content. Again, yet to see that really embedded in the creative process, but I think there's a huge opportunity there. The third category is the humanization of AI, and what I mean by that is that we can use DeepFake technology, we can use advanced natural language models to really replace the human interface with something that looks and feels like a human. And you right now, for example, might not necessarily be engaging with the real Daniel. It could be an avatar. The fourth category is I guess what you might call machine learning, but we are now able to use machine learning, deep learning even, to extract complex insights from data and help us understand the world in ways that humans would never be able to understand. They can explain now correlations that just humans wouldn't be able to spot in the data. That allows us again to be able to know things about the world. The fifth category is complex decision making, and actually this is where I'm seeing the biggest impact in these technologies. And I guess it might be traditionally called operations research, optimization, but I would controversially argue that companies don't have machine learning problems, they don't have insight problems, they have decision problems. And you see the real benefit in being able to make complex decisions better. And the final category is the extension, the augmentation of yourself, either in the physical world, whether it be cybernetics or exoskeletons, and even the extension of yourself in the metaverse. So those are the six categories. If I'm again being totally honest, I'm really only seeing a massive impact in companies in only a handful of those, but we see some promise in the others.
You made a very strong claim that there's virtually no AI in production. Surely the tech giants are using it in their operations a great deal. I mean, Google search and translate and maps and Facebook face recognition, blah 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 blah. There's surely a lot of really quite powerful AI in those systems, and they're in operation. They're commercially useful.
I think let's take two parts of the definition. So the first part is systems that can adapt themselves. Now, building systems that can adapt themselves in production safely typically requires you to have your arms around that system, and they tend to be relatively simplistic systems. And even you might argue A/B testing, is a form of adaptation. And I think one of the examples that Google did many years ago is that they A/B tested, at the scale of billions, the color of the Google link, and there wasn't a human being in that loop. It would have been billions of A/B testing and the system adapting itself to increase the clicks. So yes, there are adaptive systems in production. When I talk about the types of systems that we build for organizations, I'm talking about complex adaptive systems that have many moving parts, and if they go wrong, it just doesn't show a different color, but it can actually impact people's lives and impact businesses existentially. So complex adaptive systems are actually quite rare to find in production that are adapting.
Is that something that's going to change anytime soon?
I think that the challenge is, how do you safely build systems that can adapt themselves? And it's interesting as well when I talk to CTOs and say, I want to put a system in production that's going to behave differently today than it will tomorrow. They say, no way is that going into production. I need to make sure that my systems behave consistently from one day to the next. And if you say to a CTO that that you have to put a system in production that needs to make mistakes for it to learn and get better, they say, no way am I going to put a system in production that's going to make mistakes. And actually, for systems to learn, you have to have them make mistakes. You have to actually introduce some randomness. I used to tease Tesco when we built their last mile delivery solution that we would have to send some of their drivers down random roads just to see if those roads produce better routes. They didn't like that.
A couple of follow-ups on that. One, isn't it that the learning isn't entirely done by the machine by itself, but it throws up suggestions? Hey, how about changing this? How about changing that? And then the humans are still in the loop and will be for the time being. And secondly, can't some of that testing be done in simulated virtual worlds rather than having to actually drive down real back streets in obscure villages?
Yes, I think two questions there. I think if you're going to be building and deploying AI systems, you absolutely do either start with the human in the loop or the AI in the loop, i.e. the AI is producing suggestions for the human to execute and the human has control over the decision, or the AI is making decisions, and where it's uncertain or where it's exceeded some sort of parameters, it then goes to the human to say, I don't know what's going on here. Can you help me? I guess the aspiration is over time you move from human all the way to fully automated, but that journey is long and often underappreciated by companies. When it comes to simulations, I guess it depends on the type of problem. If you're building driverless cars, I think Elon Musk famously said recently that building a simulation of the world is infinitely more important, infinitely more complex than building a driverless car. So to really simulate all of the possible permutations, scenarios of a driverless car, you have to model the planet. There are obviously much simpler systems that you can build simulations, and actually, this is the next phase of organizations. Organizations at the moment are going through their process, going through the digital transformation process. They're buying ERPs, which I think are really just glorified databases that cover like HR and finance and sales. And what they realize is that if they want to ask a question like, if this person leaves, what impact will it have on my project? And therefore, what financial implication will it have on my organization? You can't answer that question until you join up all of these ERPs. So this is why companies are now creating their digital layer, their data lake. And what they want to be able to do is ask questions, run simulations, scenarios, and that's called a digital twin. And I think over the next decade, there's going to be a convergence of three digital twins. So a digital twin is a simulation of your organization. And there are three types of simulation here. One is the simulation of your organizational structure, so the flow of goods through your supply chain all the way to fulfilling your customer. The second digital twin is of your workforce, which you want to layer fluidly on top of that infrastructure and have them be working on the right things at the right time. And there's also a digital twin of processes. So every single company has an expense process, an onboarding process, a hiring, a firing process. Some of those processes are useful, some of them are not so useful, some of them are in people's heads. And I actually call that the company operating system. And I'm actually interested in how AI is going to be used to not only create but drive simulations in organizations across those three twins.
Speaking of digital twins, one of the things I'm surprised that we don't see yet is supermarkets offering their customers a digital twin of the shop, which you can interrogate. Because I don't spend that much time getting lost in supermarkets, but I do spend a certain amount of time backtracking and hunting around for either for a member of staff or for the tin of tomatoes that I'm after. It doesn't strike me as being all that difficult to do. Why aren't they doing it?
So the answer is they are. It's but what they can't do easily is then perturbate the system to be able to then adapt the system to be able to cater for you, Callum. So if I, for example, can predict that this weekend there's going to be a football match and there's going to be a certain demographics that's going to be coming, it's hard for a grocer to rearrange their shop floor to cater for that demographic and then rearrange it to cater for a different one the next day. So actually they are collecting that data. It's just their inability to be able to adapt their structures.
But that's them forecasting demand, which actually they do a pretty good job of. I mean, it's not very often you go to a supermarket and more than one or two of the things that you're looking for are not there. But it's just more their inability, I guess it is, because they'd do it if they could, to represent what they have on their shelves right now to me as I wander around the store. I know maintaining it, keeping it update, that's going to be an issue. They'd have to have lots of sensors around, but sensors aren't that expensive anymore. I'm just surprised they don't do it yet.
Yeah, maybe this isn't an answer to your question, but running that store requires multiple systems to be joined together and harmonized. It requires your deliveries to be coming in. It requires you to do planograms for the shelving. It requires you to do workforce allocation. And what we're seeing is organizations, as I say, going on that journey of creating their ERP infrastructure, trying to now solve these specific problems, planogram or routing or whatever, using either new technologies or technologies off the shelf. And the idea then is you can start to join them up and then optimize holistically across them. And the reality is that now organizations are realizing they need to go on that journey. And I suspect over the next 5-10 years, we will start to see some much more intelligent experiences in those stores.
So you're talking, Daniel, about organizations going on journeys. What's your advice to organizations who are trying to adapt themselves with AI? What is more likely to see them successful in their engagements, and what shortcuts might they try which you would actually recommend against?
Yeah, it really worries me that a couple of things. One is that the companies think that by creating a data lake and then putting Tableau or some sort of analytics layer on top of it, that they have AI. They think that by enabling their workforce to extract insights, graphs usually from data, that it's somehow going to provide massive amounts of value. And the reality is it doesn't, because even if you give human beings more insights, they tend not to be able to make better decisions. And so I would be, and also what we're seeing is companies hiring data scientists to solve problems across those six things I've just mentioned. They'll try and solve optimization problems, they'll try and solve generative problems, and they're the wrong skill set. So we're seeing a mismatch of talent being allocated to problems that companies don't understand. So I'm a big advocate, and this is going to sound blindingly obvious, but I'm a big advocate of identify the frictions that exist across your organization, and then prioritize those frictions according to the needs, according to the complexity, according to whether you have access to the data, according to the value it's going to add to your organization, and make sure that you're using the right technologies, the right talent to then solve them. And then over time, build up your data lake. Because building adaptive systems is much more complex than building a data lake and putting analytics on top of it. And my worry is that there's a lot of companies now creating tech debt that they have to undo in 5 years' time because they're architecting themselves in the wrong way.
That's a very interesting phrase, tech debt. I like that. One of the other things that I'm surprised hasn't appeared yet is process operations, large process operations like refineries, utilities, doing what Google appeared to do when they had DeepMind look at the cooling facilities in their server farms, their data server farms, and allegedly, and this is quite a few years ago now, allegedly DeepMind achieved a savings reduction of 40%, which is a lot, and that was on a server farm run by a very smart company, already probably pretty well run. Why isn't that appearing all over the place in utilities and in process companies?
It's a couple of things. One is to be able to make those decisions, make those changes. Often you need to be able to get access to the data and have the ability to then make changes that affect the system, and that's why I think organizations are going on a digital transformation. But Google have a lot of very smart people. Their infrastructure is probably in better shape, and I suspect, from what I understand about how they approach problems, that they do combine machine learning and decision making. So that there's again, you won't hear me say this enough, but applying deep learning to try to solve that data center problem is not enough. You need to be able to understand optimization, and so it's really, again, just that either your infrastructure isn't ready, or there's a mismatch of talent solving those problems, or not enough investment going in to solve them. You hear organizations asking AI to produce quick wins, and I often say to them that that's an oxymoron. You really have to get very, very lucky to get a quick win from any technological investment. We've seen situations where we've had 200 times return on investment, and those were lucky. Most projects are slow, they fail because of they're underinvested, all that kind of stuff. So you get out what you put in. Yes, these technologies are phenomenal. Yes, they can move the needle, but you have to get very lucky to get quick wins.
We'll be right back after a quick break.
The People in Performance podcast offers insights into the strategic competencies, behaviors, and results needed to increase the performance of employees and leaders. The show looks at all areas of the world of work, including attraction and recruitment, onboarding, training, and succession planning. Tune in to get a better handle on the stages of workforce planning you need to master in order to guarantee long-term success in a rapidly changing world of work. New episodes drop each week. Check out the latest People in Performance episodes on your podcast platform of choice. Follow us on socials and read the latest articles at pppod.com.
Daniel, if I can play back what I think you were saying, companies shouldn't be rushing to hire lots of data scientists. Rather, they should be figuring out what are the key frictions within their own processes. But how can they know what are the key frictions unless they have a good map of the data? Isn't it data scientists who will highlight things that were obvious in retrospect but weren't obvious to start off with?
I don't think you have to start with the data. I think you need to start with understanding what the problem is you're trying to solve. The two examples I often like to use in the talks I do is, we were approached by a low cost airline a few years ago, and that low cost airline was collecting data around where people were clicking, and they were collecting their purchase history, and they knew the name of your dog and how much, what you're gonna have for dinner. And they wanted to predict if you're going to churn, if you're going to go and buy from another low cost airline. And I asked them, why do you churn? And they said, well, price. And I said, well, are you collecting your competitor prices? And they said no. So they thought that somehow they're going to be able to predict churn, but the signal is in the competitor prices. And the second example is, and this is not mine, this is somebody else's, is a short-term loan company wanted to predict if people are going to default on their loan. And they were using social data, LinkedIn, Twitter, all that kind of stuff, to try to understand human behavior and determine default. And all of that data was useless. There were two good predictors of loan default. One was a font, a typeface that was kept in your internet cache, which is often found on gambling websites. So if you're a gambler, you're likely not to pay back your loan. And the other one was how many mistakes you made when you were filling out the online application form. And that was an indication that you were intoxicated or high. And so I remind people, you start out with the problem that you're trying to solve, and then you ask, usually domain experts, what data do you think you need to be able to find the signal to help solve that problem? Usually human beings actually know the signals. You don't have to start with a data lake to find these needles in a haystack. Human beings tend to already know where to look.
And I've heard you say that a lot of the work going into compiling data lakes is going to be wasted. What are the sort of things that people are doing wrong as they assemble their data lakes now? What should they do?
The way that they store the data is not necessarily conducive for applications, for example, that need to run in real time. You then have to, if you want an application that needs to operate in seconds or milliseconds, that you can't be pulling that data from a data lake. You need to put it into an in-memory database or something else to be able to get that, to query it. And then what you need to do is you need to synchronize that data pool, forgive the water analogies, with the data lake, because if you don't synchronize it, now you have a mismatch of data. And so you end up actually having to create data pools to actually supply most of your applications. You also usually have to have batch situations. So let me give you an example. In what we're starting to see now is organizations wanting to understand the skills of their employees, the activity of their employees. And you can look across email and your communication channels, your code repositories, your document management systems to try to actually profile people's skills and their activity. Now, to be able to do that in real time is impossible because it requires natural language processing, image processing, all of this kind of stuff. So you end up having like a batch AI that's scouring all of that content and then trying to profile you every night or every week or every month. And that's what you pull from the database. And you can imagine all of these things that I'm mentioning to you require a lot of complexity that I think unfortunately organizations are failing to appreciate.
We've been a little negative about AI on this episode so far. Let's see if we can pull out some positive. What's your favorite AI, or at least near AI, project that you've worked on or seen operating to date?
I mean, we have tons. So I think we've been very lucky because my background is both in deep learning and in optimization, and I really spotted the importance of being able to harmonize these two things to move the needle for organizations. So for the most part, we see a benefit where these two things come together. And obviously, Satalia was one of our first biggest clients was Tesco, and it's one of the ones that I am most proud of because Tesco wanted to build a last mile delivery solution. They could have bought something off the shelf that had millions of investment over the years. They were very brave to say, we want to build this ourselves. This is going to be a differentiator for us. They understood that underneath it required complex algorithms, and they understood that we could build those. And we built a solution within 6 months was beating state of the art because we were able to pull the best algorithms from academia, we were able to combine it with machine learning. And what we're doing now is saving Tesco probably 20 million miles a year, which is to the moon and back 50 times in terms of impact. And these technologies really can move the needle, not just commercially, not just helping organizations do less with more or sell more stuff, but could have a material impact on their environmental footprint. So and the second one that comes to mind was actually with PwC, where they have thousands of auditors that they need to work on projects, and historically human beings would be trying to solve this very complex maths problem, which we solved incredibly quickly and incredibly well. And I just think the amount of lives that is impacting, people now doing work that are fulfilling, that they are developing their careers. Again, we had an environmental impact as well. So we tend to work on projects that really do free people up from mundane tasks, whether it be planners or whatever, but also make sure that the people on the coal face, the people who it's affecting, are actually having a better experience.
And key to this, you said, was not just data science, but optimization. So how do people learn about optimization? Is there a whole discipline? Is that mathematics or something different?
It used to be called operations research, David. I guess it's a field in computer science that matured in academia a few decades ago. And I guess if you were to Google keywords, it would be like discrete mathematics, logic, operations research, and what we're going to see, I think, over the next few decades is a moving away from machine learning. So everybody get excited about machine learning again, and we're going to start to see, I think, more and more emphasis on the combination of the two. You still find across pockets around the world operation research being invested into Brazil, in the Germanic countries, in Australia, Portugal, even in the north of England. So I think that companies are really waking up and realizing that they need to have these two types of skill sets.
And those large scale applications you were talking about with Tesco and PwC, would you describe those as genuine AI, or are they kind of pre-AI in the way you were describing earlier?
So within those systems, you have multiple optimization algorithms, you have multiple machine learning algorithms. The Tesco stuff, I mean, we internalized that with Tesco. Tesco then took that on, have been developing that themselves. I suspect that there isn't some sort of self-learning component. But the way that self-learning works, I guess, in resource allocation is you allocate people to work. Then there's a machine learning that determines whether they worked well in those teams, whether the client's happy. So it pulls together data from feedback and all sorts of stuff that you can then reprofile the skills of those people, understand what work they want to do, so that then the optimizer can then allocate them better in the future. So in some respects, you could argue that feedback loop is complete for the likes of PwC.
You have applied, I believe, some of these ideas in your own company at various times, talking about applying a feedback loop. So can you say how these experiments have gone on at Satalia and are now possibly working at WPP?
Yeah, I think one thing to kind of get across here is that intelligence is synonymous with adaptation. So the faster you can adapt to a changing world, the more intelligent you are. And so organizations are realizing that it's not just about building systems that can adapt themselves, but it's about building adaptation into your organizational culture. And so that's why they're adopting things like Agile and Scrum and design thinking. The principle behind these methodologies are for you to be able to adapt more quickly to a changing world. And so when you start a business, you're usually going after a product or a service. You create an organizational structure that's optimized towards one or the other, and the pressure or the opportunity to diversify your revenue streams means that you'll end up doing a whole plethora of things. You'll do products when you're a services company, a service when you're a product company. You'll sell assets, you'll sell frameworks, you'll do consultancy, and your organizational structure isn't necessarily set up to be that fluid. So very early on in Satalia, I wanted to organize ourselves, create a new operating system for a company that allows for fluidity across a company that could offer multiple revenue streams. I guess you might argue that that's a venture builder, a company that spawns innovations and tries to get those innovations to market as fast as possible. And over the past 10 years, I've been thinking about how new organizational structures, new organizational paradigms can be leveraged using AI to create incredibly adaptive organizations. And so what the principle behind how Satalia operates is we try to identify the best group of people to be able to make the best decision. So instead of that decision making existing in a hierarchy, can you spawn the hierarchy based on what the AI thinks is the best group of people, empower them to make the decisions, and then move on. And so over the past decade, we've been, I think, pioneering new ways of organizing ourselves. We used to get people to make public recommendations for their salary, and then people would vote on whether their salary should be reduced or increased or kept the same. And we use AI to determine how many votes one person has for another. So by looking at your digital footprint, I can see how many votes you should have for Callum, for example, because of your proximity, how knowledgeable you are about his domain. And I think that we could apply this liquid decision making, this is what Silicon Valley now call liquid organizations, to any decision that exists in an organization. And we're about 120 people when Satalia was acquired, but my goal isn't just to scale that to WPP, 120,000 people, and create a liquid organization of 120,000 people. My goal is to scale that to a planet. I think we should try and create an operating system that everybody has the chance to work on what they want, where they want, how they want, and be fairly remunerated for that contribution.
Daniel, I just think you're nowhere near ambitious enough. Actually, you've shown me what this system looks like, the kind of digital twin for Satalia, and the way that you're giving people data to make decisions about their own work and about their colleagues' work, and pushing those decisions down into the organization and trying to avoid having any kind of hierarchy at all. I can imagine when you describe that to the people who run WPP, they are silently shuddering. I mean, are you getting them to adopt any of these approaches?
Absolutely. So we are now we're engaging with the majority of the opcos across WPP. It's interesting because when you speak to the heads of people, the HR leads, they all want to operate like this, right? They all want to figure out, how do you identify the best skilled people to work on the best projects that maximizes the value to the business, but also maximizes value to the individual, the client, the partners, and the environment. And historically, you just couldn't do that. It was such a complex problem. I often remind people that if I've got 60 people that I need to allocate to 60 jobs, it's the 60 factorial. There are more possible combinations than there are atoms in the universe. So in PwC, there's 5,000 factorial, and so we can use AI to solve that problem, to allocate people to work that aligns with the values of the company, the values of themselves. But we can then use machine learning to understand the nature of those people, their skills, their preferences, their hopes, their dreams, their desires, so that we can then better allocate them in the future.
Well, Daniel, I think sadly we're just about out of time. We could talk about this all day. I'd certainly like to say that your vision is very exciting, and I look forward to seeing you roll it out across the world.
Thanks, Colin.
Indeed. So it sounds like there's a third skill set that's needed. It's not just the optimization, it's not just the data science, it's also the agility or the fluidity or the willingness to have your organization adapt on a regular basis. And that's more than just something technical. That's got to be something soft or emotionally intelligent as well, I'm guessing.
It's being able to get innovations to market as fast as possible. And the process of innovation requires way more than a technological solution. It requires the unlocking the creative capacity of your workforce, empowering them, giving them psychological safety, and then getting those ideas to the point where somebody's willing to pay for them. The faster you can innovate, the faster you can adapt, the more intelligent you are.
We might have you back some other time if you will be willing to talk more about liquid organizations and moving this from the company level to the world level, because I share your vision. We have to get out of our rigidity, but not just fall over on a heap when we loosen up our hierarchy. How to maintain what's good about the existing structures, but evolve it further.
Absolutely. I think that these technologies and structures have a real promise to be able to reduce the cost of goods, making them abundant, because we can remove so much friction from them, but also give people new opportunities to work in ways that they currently can't. And I think that may take the edge off some of the challenges that we're facing over the next several decades.
Many thanks, Daniel.
Thank you, Daniel.
Thanks, David. Thanks, Callum.